Okay, hey everyone, this is a video on how to make a juicy 2D camera in Godot. This is based off of a game developer conference talk I watched, which primarily focused on the novel idea of using OpenSimplexNoise as a way of making your camera motion smooth and work under strange circumstances like slow-mo. The basic gist is we're going to control our camera with a trauma variable that's going to say how much we're going to be shaking our camera. And we're going to read noise from the current time to figure out how much we're going to offset ourselves by. But it's much better shown through code. So let's dive into Godot. We're going to want to create a new scene, and we're going to want to create a camera 2D. We're going to want to set our camera 2D to be current so that it's what's actually used when we're in game. And we're going to want something we can look at. So I'm going to set up a simple scene, I'm going to drag the Godot icon in, and let's create something that will look like the floor, because when you've got screen shake, having some perspective is very helpful. So let's nab a polygon 2D. And let's draw out a simple box at the bottom. I have snapping turned on, shown by these two green icons here, that mean my clicks will latch onto the grid you can see on my screen. There we go, let's make that black. And let's start fiddling with our camera. So our camera is current. We're going to, let's move it up a bit. You can hit W if you want to move, and then if you drag around, it will move like that. So let's attach a script to our camera 2D. Let's call it Juicy Camera. In here, we're going to want to export a variable that will contain our noise. So we can do that by saying export, and then you can give a data type. So we're going to say OpenSimplexNoise, and define it as a variable and call it noise. And let's save the scene as Juicy Cam. If you ever want to know more about a class that's built into Godot, you can hold Control and click on the name. It should get an underline like that, and it will take you straight to the docs for it. We're going to be using some of these get noise functions, but I'm getting ahead of myself. So now we've exported that variable, we can click on our camera 2D, and that variable's been added to our inspector on the right here. So you can see we've now got a field called noise, and you can populate that with an OpenSimplexNoise. You can create OpenSimplexNoise in script, well, in the code. You can say new OpenSimplexNoise. However, due to, after I saw a tweet by GDQuest, it's been brought to my attention that instancing variables like this is actually more, it hits your performance harder. So it's better to actually create objects in editor whenever you can. So let's create a new OpenSimplexNoise. This has some parameters that you can fiddle with, but happily we're not going to need to. So now we've got our OpenSimplexNoise, we're going to want to export a few other variables. We're going to control how much our camera shakes by using a variable we're going to call trauma. So let's export a variable called trauma. And this is going to be a float, so it's going to be a decimal number between 0 and 1. So let's export float and then 0, 1. I do believe that will, I'm doing this slightly wrong. It's export float, 0, 1. That is going to, in editor, give us the option to create a float within the range of 0 and 1. And let's call that trauma. Let's default that to 0. So now if I jump back to editor, we should also have a trauma value, and you can see we've got a slider to go between 0 and 1. Very handy. Now, dive back into the code. We're going to want a few other variables, but let's come to them later on. Let's get into more juicy stuff. So, we're going to want our process function. This runs every frame. You should be used to it. Delta is a variable that tells us the time since the last frame. We are going to want to keep a track of the current time. Now you can do that, because delta is the time since the last frame. If we keep a tally of our deltas, we will have our current time in milliseconds, I believe. So let's save a variable called time, set it equal to 0, and then in process we're going to say time plus equals delta. So that means every frame we're going to add this very small amount of time onto time, and it will be up to date. We're then going to want to figure out how much trauma we're going to apply. Now, in the Game Developer Conference video I told you to watch, he recommends you square your trauma. So what that will do, because trauma is a value between 0 and 1, it means the value we access if we're using trauma squared, if I call that shake. Let's just do that first and then I'll talk about it. Shake equals pow trauma 2. Pow is a function that raises an exponent to a power. So in this case, it will raise trauma to the power of 2, so it will square it. So if you have a value between 0 and 1 and you square it, that means when you have small numbers, when it's below 0.5, you're going to have smaller numbers. So 0.5 squared is 0.25. So you can see once you've got halfway up the trauma value, you've only got a quarter of the way up your trauma squared value. And then you'll very quickly approach 1 as your trauma value approaches 1. So it means our shake's going to be kept lower most of the time, which is also nice. And it also means we're going to lose it at a more interesting rate as well. So we have this shake value, and we're now going to want to grab a value from our noise. So noise, when you generate OpenSimplexNoise, you get 3-dimensional noise. That means we have 3 dimensions of values we can access that all vary smoothly over time. I suppose it's worth me mentioning in a bit more detail, noise will generate an area of values between 0 and 1 that smoothly update. So if I go over here, I add a sprite, just to show you quickly. If I update this to be new noise, a new noise texture, and if we put new OpenSimplexNoise on that, you can see we've got this whole misty looking area. And what this is it's a load of values where the black values are the noise be approaching the value of 0, and the white value of the area is approaching 1. And it will smoothly go up and down in all dimensions, and the parameters determine how it'll approach and how smoothly it'll transition. Let's jump back to our camera. We're going to want to access these values. Now I said it was 3-dimensional. You can also access a Z value that goes into the screen, and they're also unique values. We want three smoothly changing values, and the values we want are how far we're going to move to the left and right when we shake, how far we move up and down when we shake, and how much we rotate when we shake. So let's set how much we move left and right. That's going to be offset.x. That's how much we're offsetting our camera in the x-axis. And we're going to set that equal to noise.get noise 3D. As I showed in the docs earlier, get noise 3D. This function takes an x value, a y value, and a z value, and it returns a float. So if we put the current time in as one of these coordinates, so if we put the time in as the x and we have the others as 0, if you can imagine moving on one axis along a surface that is increasing and decreasing to values of 0 and 1, as time increases, we will get smoothly changing values. So after a certain amount of time, we'll be around here, and after longer, we'll be around here, but we'll have smoothly gone to each of those points as we move. And this, the way it's distributed on the x-axis, is different to the way it's distributed on the y-axis. That could distort in a totally different way. So we can use this one load of noise with the same parameter in different directions and get smoothly changing noise that's unique. As you can see here, you even get 4D, which is an option I didn't know about. Let's jump back and say plug in our x coordinate. To keep things simple, we might as well plug in the variable on our x as our x parameter for getNoise3D. So what we're going to want to pass in is time, and then set the others to 0. So now we're getting this noise on the x-axis. Our time is going to be quite small. We could use parameters to tweak how quickly our noise changes its value, but I think it's more sensible to just multiply our time by a constant amount. I'm going to say 100. That means it's going to more quickly move through its transitions from low to high numbers, because if it's too slow, you won't notice it slowly moving left and right. We're then going to want to multiply that by an amount, because at the moment we're getting a value between -1 and 1. So we want to make that a more sensible amount, because otherwise we're going to be moving about a pixel left and right, which you just won't see. So let's multiply by a max x change. And also multiply it by how much we're shaking by. We need to define this max x, and we're also going to want to define a max y value and a max rotation value. So I'm going to populate that for us now. So we now have a value that's offsetting on the x-axis. So if I set the trauma value to something sensible, something big, and I run this scene, you can see we're smoothly moving left and right, and because it's fast, it's the camera shaking left and right. This is exactly the effect we wanted. So we're also going to want to apply this vertically, so it will move up and down, and also rotate, although that's optional. It's a useful option to have. So let's go and set up the Y changes. This is exactly the same process as X, but we're going to use the other axis of our getNoise3D function. So let's set offset.y, and then instead of passing in an X coordinate, let's set the X coordinate to 0 and only change the Y parameter. And let's see how that looks. Awesome. Let's do the rotation too. The rotation, we can control it with either rotation or rotation degrees, depending on whether you want to use radians or not. I'd recommend using rotation degrees. Most of the time it's simpler. And now we're going to want to plug in our Z value rather than our Y. And let's look at that. It isn't rotating because I forgot a key step. You need to enable rotation on cameras with this field here. That rotation is much too much. Let's make that more sensible. I forgot a key step. I set max x to be my value in all, so I wasn't updating max r to something sensible. Let's set it back and try using the proper max values. There, that's a lot more reasonable. I'm tempted to speed up the camera a bit. So we can do that by changing the amount we multiply our time by. Let's set that as a constant to make it easier to fiddle with in the future. There we go. Now that's pretty extreme. The next thing we want to do is we want to make affecting our trauma value more sensible. We've currently just set it straight to a high amount of trauma, but in-game you would likely want to contextually add some trauma to the camera. Say when they've taken a hit, add about 0.5 or something, so you get a bit of shake. If things are going crazy, add a lot. So let's make a function that adds to our trauma and locks it to a sensible value. That's quite simple with the clamp function. Define your function, we're going to call it addTrauma. Give it a parameter, that's the trauma going in. And then we're going to set our trauma value to be equal to what it currently is, with trauma in added to it, and then we're going to clamp it to 0 and 1. Clamp takes a first parameter and will return that unless it's greater than a minimum value and less than a maximum value. So if we give it a minimum of 0 and a maximum of 1, it will return the value. If it's less than 0, it will lock it to 0. If it's higher than 1, it will lock it to 1. Okay, great. We now want our trauma to decay over time. It's best if we declare a variable that is how quickly we're going to decay, but we want, after it's been shaking for a while, to return to normality. So let's set a decay variable, and then in process, let's decrease trauma over time. So we've set that as a value between 0 and 1, and we're going to set it to be 0.6. And then let's say if our trauma is greater than 0, so if we're in a circumstance where we want to decrease, we will decrease it, and we're going to want to clamp it again, so it can't become less than 0. Okay, fantastic. So if we're going to want to test this out, it's probably for the best if we add a button that will add trauma. We're going to want to put all of our stuff on a canvas layer. A canvas layer will follow the camera around, as I describe at some length in my full screen shaders video, but we want it to follow the camera because the screen's going to be shaking and it's going to make your life really difficult if you're trying to drag a slider around and your screen's moving. So let's go back to the 2D view. Let's add a child of our camera and make it a canvas layer. And then let's add a button. Let's put it in the middle for fun. So you'll notice it draws to the bottom. It's not drawing where the camera is at the moment. That's just to do with the way canvas layers work in 2D. They draw from their origin, but when the game is actually running, the canvas layer will be drawn over the camera 2D. Let's add some text, and let's say add trauma. This button's going to be a little small, so let's increase its size by scaling it up. Let's not put it in the middle. Let's put it in the top. There we go. And we're going to want to hook this button up to our camera 2D. We're going to click the Node tab at the top right, click on the pressed signal and then connect it to our camera 2D. It should just connect to whatever script you've got open ahead of time. You can choose the name of the method, but let's just do things quickly. So now, on button pressed, we're going to want to add some trauma. And let's set that to something sensible, like 0.3 or so. You can see off the bat, we started with trauma from earlier, but it decayed on its own because of that decay function we put in. So now if I click add trauma, we will get a bit of jostle. That's because we are offsetting by our trauma squared. So you need to add quite a lot of trauma before you actually get shake. But if you do a little bit, you will still get some. And even a little bit of tactile feedback to the players is worth a lot, and probably recommended because you don't want to distract them too much with this kind of effect. For ease of viewing, I'm now going to add some progress bars that will show the value of our trauma and our shake. Now, in our process function, I'm going to simply set the value of those two progress bars to show how our trauma and shake is over time. So you can now see at the bottom of our screen, we have a green bar and a red bar that show our trauma and our shake. The top bar should be the trauma, the one in green, and the red bar should be the shake. And you can see that the green bar rises quicker than the red bar. That's because that's showing you exactly how those powers interact. But when they get close to the top, the shake's close to the top. And then you can see exactly how the shake bar moves as it decays over time. It gives us an exponential sort of curve to our transitions, and the video recommended it, and it's really good. So, we have that all set up. Next, it's probably in our best interests to try out time scaling. Yes, so one of the main reasons we wanted to do this approach with noise is it lets us behave interestingly under strange conditions like slow or fast motion. Godot handles changing the timescale of the game very easily. It's done with an engine.timescale variable, and it will slow or speed up everything. So let's try that out. Let's add a slider that will control how fast our timescale is moving. So let's just add a V slider. Set it to fill the left. And let's set it to go between a value of 0 and 2. And go up in steps of 0.1. Now we can connect its value changed function, connect that up to our camera, and set engine.timescale to be set to this value. Now if we run things, I missed something, we're going to want that to default to 1. So now if we run it, I'll show you it normally first, we'll add some trauma and it'll behave as expected. If I slow things down, you'll notice that the jostling left and right is in slow motion. Now, the alternative, not using OpenSimplexNoise, you would probably use a random number generator. If you were using a random number generator, you wouldn't get smooth motion from one position to the next. It would jump about a lot, which at a cursory glance would look like what you wanted. But if you tried to slow things down, it would always jump from one point to the next at the same rate. Because we're accessing noise based on the current time, if we slow time down, we will move from one point to the next slower. And that's why we get everything looking really, really nice when we try to add trauma to things slowed down here. For more evidence that time is moving slower, if you watch the bars at the bottom, they will fall much slower than they did previously. We can slow the timescale all the way down and you can see exactly how the camera's moving on a more granular level. And of course, this also works if you speed things up. And I believe that's everything. You've now got a camera that will update to shake based on an amount of trauma that can be provided in a very convenient manner based on damage or whatever other environmental effects you want, and will also be based on the time of the game, so it will work in slow or fast motion. I pretty much use this camera in any 2D project I open. I will just drag over the juicy camera and put it in the new game, and I will very quickly have a way of adding some much needed response to in-game actions like falling. I can't recommend this enough, and you can find all my code on the GitHub. Additionally, I'm probably going to show you some footage of me using it in other projects I've used at the moment. So in the most recent Ludum Dare entry I did, I added screen shake when you fell, which felt really, really good. In the game I'm currently working on, Degrees of Freedom, I use it under many stressful circumstances. For example, there's a sun that talks to you, and it makes the whole screen shake when it talks to you. There's a nice added effect as well. I add a little bit of chromatic aberration to the screen whilst it's shaking. That's a nice extra bit of feedback that you can easily implement yourself by following my full screen shaders tutorial and hooking that up to work based on the same trauma parameter we're using here. That's the full effect. Thank you very much for watching. Please do like and subscribe or anything else like that. It really helps the channel out. See you all soon.